Hey everyone, welcome back to the channel. Today we're diving into something truly exciting, a brand new way to find the derivative of exponential functions like e to the power of x and y to the power of x. You've probably learned the traditional methods using natural logarithms and the number e, but what if I told you there's another way? A way that uses something called the s function. Stick around because by the end of this video, you'll not only understand this new method but also see why it matters. Let's get started. Before we jump into the new method, let's quickly recap what we already know. In traditional calculus, the derivative of e to the power of x is simply e to the power of x. That's right. It's one of the most beautiful properties of the exponential function with base e. But what about y to the power of x, where y is any positive number? The derivative of y to the power of x is y to the power of x times the natural logarithm of y, where natural logarithm of y is written as ln of y. These results are fundamental, but they rely heavily on the natural logarithm and the number e. So what if we could find these derivatives without using e or ln? That's where the s function comes in. Let me introduce you to the s function. It's defined as s to the power of x equals 1 plus x squared over 2 plus x cubed over 3 and so on for x less than 1. This function might look familiar. It's similar to the Taylor series expansion of e to the power of x, but it's not the same. The s function is a new tool that we'll use to find derivatives of exponential functions in a completely different way. The key idea is to express exponential functions like e to the power of x or y to the power of x in terms of the s function. Let's see how this works. Let's start with e to the power of x. Using the definition of the derivative, we write the derivative of f of x equals the limit as h approaches 0 of e to the power of x plus h minus e to the power of x all over h. We factor out e to the power of x and rewrite e to the power of h using the s function. E to the power of h equals s to the power of h times log base s of e. Expanding e to the power of h using the s function, we get e to the power of h equals 1 plus h times log base s of e plus h squared times log base s of e squared over 2, and so on. Substituting this back into the derivative expression and simplifying, we find the derivative of f of x equals e to the power of x times log base s of e. And there you have it, the derivative of e to the power of x using the s function. Now let's generalize this to y to the power of x. Using the same steps we start with. The derivative of f of x equals the limit as h approaches 0 of y to the power of x plus h minus y to the power of x all over h. We factor out y to the power of x and rewrite y to the power of h using the s function. Y to the power of h equals s to the power of h times log base s of y. Expanding y to the power of h and simplifying, we arrive at the derivative of f of x equals y to the power of x times log base s of y. This is the derivative of y to the power of x using the s function. No natural logarithms or e required. So, why does this matter? Well, the s function gives us a new perspective on exponential functions and their derivatives. It shows that we don't always have to rely on e and natural logarithms to solve problems in calculus. And that's it. We've explored a new way to find the derivative of exponential functions using the s function. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and subscribe to the channel for more math content like this. Let me know in the comments what you think about this method. Would you use it, or do you prefer the traditional approach? Thanks for watching, and I'll see you in the next video.